Okay, let's unpack this. Imagine digging in your backyard, right? And you unearth these bones that scientists nearly 2 centuries ago,
Wow, yeah.
back in 1818 in East Windsor, Connecticut, they actually thought they belonged to a human.
A human. Seriously.
Seriously. That's basically how the story of one of North America's earliest dinosaur discoveries began. So today, we're taking a deep dive into that dinosaur, Anchisaurus.
Okay.
Think of it like unlocking a prehistoric puzzle. Starts with this case of mistaken identity, and we'll follow the clues to see where it fits in the whole dinosaur family tree.
And what's really fascinating here, even with that initial mix-up, this discovery was actually a pretty significant step, in understanding the ancient life that once roamed North America.
Right.
These Anchisaurus fossils, they come from the early Jurassic period, specifically from what geologists call the Upper Portland Formation over in the northeastern U.S.
Okay, early Jurassic.
Yeah, that puts them at roughly 200 to 192 million years old. So during the Hatangian and Cinemurian ages...
Okay, for those of us maybe less familiar with the geological timescale, can you give us a quick sense of where those periods fall? Within the early Jurassic, I mean.
Sure. So the early Jurassic is just the first slice of the whole Jurassic period.
Right, the middle part of the age of dinosaurs.
Exactly, the Mesozoic era. And the Hatangian and Cinemurian, those are the earliest stages within that early Jurassic time frame, like right at the beginning.
Got it. So our mission today is to figure out why this specific dinosaur, Anchisaurus, is significant. What does its story tell us about the beginnings of paleontology and dinosaur evolution? But, without getting totally bogged down in jargon.
Well, that raises a key question right off the bat. How does a dinosaur get mistaken for human remains?
Yeah.
And that 1818 find in East Windsor is just a perfect example. Solomon Ellsworth Jr., he was digging a well, and they were using this gunpowder.
Gunpowder to dig a well.
Yeah. Not exactly precise archaeological technique.
Not really.
So this meant the bones got pretty damaged. And because of their size, the whole thing was nearly 6 feet long. The initial thought was, well, it must be human.
6 feet long. Okay, yeah, back in the early 1800s, I can kind of see how that might be the first conclusion. But what clued them in that it wasn't human?
The crucial bit was finding tail vertebrae.
Oh, right.
Obviously, human anatomy doesn't include a bony tail. Yeah. So that realization really shifted things, even if they weren't sure what kind of animal it was yet, just not a person.
Okay.
Then later, in 1863, more remains turned up in Springfield, Massachusetts, during blasting at the Springfield Armory.
More blasting.
Yep. And sadly, these were also fragmented, kind of scattered all over.
Man, it sounds like the early days of dinosaur hunting were a bit destructive.
That's a fair assessment. So Edward Hitchcock Jr., his father, was also a paleontologist. He described these Springfield finds. And he even reached out to Richard Owen.
Richard Owen, okay, he was a huge figure in early fossil studies, wasn't he?
Yeah.
Very influential in Britain.
Absolutely. A giant in the field. Owen looked at the fossils and suggested the name Megadactylus?
Megadactylus.
Which means large finger in Greek. He was referring to what they thought was this really big thumb bone.
Okay.
But Hitchcock Jr., he went with Polyzelus instead.
Polyzelus.
Yeah, meaning much sought for. It was sort of a tribute to his father, who had been really interested in these mysterious fossil footprints found in the area for a long time.
Ah, so bit of a naming debate right from the start. Megadactylus does sound pretty descriptive, though. Why didn't that one stick?
Well, here's where it gets really interesting and kind of messy.
Oh.
The name Megadactylus, it was already taken. It had been used before for a type of lizard.
Oh, no way.
Yeah. This whole issue of Cree-occupied names, as they call it, is a super common headache in taxonomy. The science of classifying life. You just can't have the same scientific name for two different things.
Right. That makes sense. So back to the drawing board for the name then. What happened next?
So then Othniel Charles Marsh enters the picture. Another very important, sometimes controversial figure in American paleontology.
Ah, yes.
In 1882, he proposed Amphisaurus, which means near Saurian.
Near Saurian. Okay.
And this probably reflected his thinking at the time that this dinosaur Anchisaurus, well, what would become Anchisaurus, was sort of an intermediate form between more primitive dinosaurs, like Paleosaurus was considered back then, and the more advanced types.
Like a link in the dinosaur evolutionary chain.
Kind of, yeah. That seems to be the idea. But, believe it or not.
Don't tell me Amphisaurus was also taken.
You guessed it. Amphisaurus was also preoccupied, this time by an Amphicosauриan that's an early type of four-legged animal, not a dinosaur at all.
Wow. So Marsh had to try again.
He did. Third time's the charm, right?
Oh, well,
So in 1885, Marsh finally settled on Anchisaurus. And funnily enough, it actually means something very similar to Amphisaurus, near lizard.
huh. So after all that trouble, the meaning basically stayed the same.
Pretty much. The whole journey just to get the name Anchisaurus settled was quite the roller coaster. It really highlights how tricky it was for early paleontology to set up consistent, unique names as all these new discoveries were pouring in.
What a saga, just for a name. But presumably things started to get a bit clearer when more complete fossils turned up.
You'd think so, wouldn't you? But there were still more twists in the tale.
Oh?
Yeah. In 1884, during bridge construction over in Manchester, Connecticut, at a place called Wolcott's Quarry, some much more complete, really significant remains were found.
Bridge construction again. Tell me more. It's amazing how much drama there is behind these scientific finds.
Isn't it? So an amateur paleontologist, Charles H. Owen, noticed the sandstone block, and it had the back half of a dinosaur skeleton in it.
The back half.
Yep. He contacted Marsh, who managed to get hold of it. That specific fossil is now cataloged as YPM 208.
Okay.
But here's the wild part. The front half of that exact same skeleton had already been used unknowingly as part of a bridge abutment.
You're kidding? It was built into a bridge.
Literally built into the bridge structure. It wasn't until way later, 1969, that another paleontologist, John Ostrom, actually managed to find and retrieve those missing front bits.
That is absolutely incredible. Part of a bridge. Wow.
It's a great story, isn't it? And that wasn't all from that quarry. A second, pretty complete skeleton, now known as YPM 40313, was also found nearby.
Okay, so more material.
Right. Now, Marsh, in 1889, he named that first hind part YPM 208 Anchisaurus major. But then, just 2 years later, in 1891, he decided it was different enough to create a whole new genus for it. Ammosaurus.
Ammosaurus.
Yeah, meaning Sandnosaurian. And he also named that second skeleton, the more complete one, YPM 183 YPM 40313. He called that Anchisaurus coloris.
Coloris, what does that mean?
It means the mangled one.
The mangled one. Another slightly unflattering name. Okay, so now we've got Anchisaurus polygellus, Anchisaurus major, Ammosaurus, and Anchisaurus coloris, all floating around for fossils from the same basic area.
Exactly. It got pretty confusing. And these Manchester specimens, the Ammosaurus and A. coloris, they were what Marsh mostly used for his big skeletal restoration of Anchisaurus in 1893.
Okay.
But our understanding has moved on quite a bit since Marsh's time. Today, we basically consider Anchisaurus major, the one he renamed Ammosaurus and Anchisaurus coloris, to be the same species as the original Anchisaurus polygellus.
Ah, okay, so they're all just Anchisaurus polygellus.
Pretty much, yeah. The differences Marsh saw are now mostly thought to be just variation within the species, or maybe different growth stages, younger versus older animals. So all those names ultimately point back to the same dinosaur.
So all those different names finally got sorted out.
Well, to make it official, yes. In 2015, the ICZN, that's the International Commission on Zoological Nomenclature, the body that sort of governs animal names,
Right.
they formally designated that more complete A. coloris specimen, YPM 188340313, as the neotype for both the genus Anchisaurus and the species A. polygellus.
A neotype.
Mm-hmm.
That's like the official reference specimen when the original one, the holotype, is lost or not good enough.
Sure.
Right? Why was setting that up important here?
Exactly. It nails things down. This official designation means that A. polygellus and A. coloris are now considered objective synonyms. Basically just two names locked onto the very same reference fossil. It cleans up the historical confusion.
Okay, that helps clear up that whole naming tangle.
Yeah.
So now that we kind of have a better handle on who Anchisaurus is,
Yeah.
what did it actually look like? And circling back to the very beginning, why the mix-up with human bones?
Well, that initial mistake makes a bit more sense when you think about the size. Anchisaurus was actually a relatively small dinosaur.
Small.
Yeah, just over 2 meters long, so about 6.5 feet, and probably weighed around 27 kilograms, which is roughly 60 pounds.
Okay, 6.5 feet, 60 pounds.
Yeah.
Yeah, I can definitely see how that skeleton might initially be mistaken for a human, especially if it was incomplete or damaged.
Exactly. So definitely not the giant, ground-shaking dinosaurs we often picture from the Jurassic.
Not at all. Although, didn't Marsh think his A major, the Ammosaurus one, was bigger?
He did, yeah. Initial estimates for that one range from maybe 2.5 up to 4 meters long and weighing up to maybe 32 kilos or 70 pounds. More recently, Gregory S. Paul, in 2010, estimated it a bit smaller, around 2.2 meters and 20 kilos. So still in that general ballpark.
There's still a bit of a range in those estimates, isn't there? What might account for that variation for what we now think is the same species?
Well, several things. The fossil record is patchy, right? We often only have bits and pieces, so figuring out the full size can be tricky.
Sure.
Plus, like most animals, Anchisaurus probably grew throughout its life, so we might be looking at fossils from younger, smaller individuals and older, larger ones. And just like people, there was probably natural size variation within the population too.
Okay.
But what's really interesting is that there's also footprint evidence tracks called CF Autozoom found in the Connecticut Valley that might suggest some Anchisaurus individuals got even bigger.
Bigger than 4 meters.
Potentially, yeah. Based on the known bones, paleontologist Adam Yates estimated they could have reached up to maybe 4.9 meters, so around 16 feet.
16 feet. Okay, that's a pretty significant jump from 6.5 feet.
It is, and some researchers have even looked at the very largest Eubrontes footprints. Those are thought to be made by similar early Sauropodomorphs and speculated that maybe, just maybe, some exceptionally large Anchisaurus could have hit like 6 meters, nearly 20 feet.
Wow, 20 feet. So we're dealing with a dinosaur that had quite a potential size range then. What about its overall build, its posture? What kind of dinosaur was it thought to be originally?
So originally, because it had certain features that seemed less specialized compared to later giants, it was classified as a prosauropod.
A sauropod. Okay.
Yeah, that group was generally seen as being close relatives or maybe even direct ancestors of the huge sauropods like Brachiosaurus. But more recent studies suggest Anchisaurus is actually positioned a bit closer to the base of the sauropod family tree itself.
So not quite a direct ancestor, maybe more like an early cousin on the path towards sauropods.
That's a pretty good way to put it, yeah. It shares features with both the earlier forms and the later, more specialized sauropods.
Okay. And how did it move? You said it could be mistaken for human size, so maybe bipedal,
Well, the current thinking is that it was probably a facultative biped,
meaning.
meaning it likely spent most of its time walking on all fours, but it definitely could rear up and walk on its hind legs when it needed to, maybe to reach higher vegetation or get a better look around.
Okay. Multi-purpose limbs then.
Exactly.
Right.
The front limbs were actually quite adaptable. They could rotate inwards, allowing for some grasping ability. And it had this first finger that was sort of reversible, almost like a thumb.
A grasping hand.
To some extent, yeah.
Wow.
And on the hind feet, it had 5 toes that could lie flat, providing good support. It's a fairly unspecialized limb setup, pretty typical for many early dinosaurs.
Interesting. What about food? What kind of teeth did it have?
It had these spoon-shaped teeth. They look pretty well suited for stripping leaves or tearing up plant material.
Okay, so primarily a plant eater.
That's been the main thought. Interestingly, though, it had fewer teeth, and they were more widely spaced than some other early herbivores. And there's some intriguing evidence suggesting its diet might have been a bit more flexible.
Oh, what?
Well, fossils of similar early sauropodomorphs found up in Nova Scotia in the McCoy Brook Formation. These were initially thought to be related to Ammosaurus, but now they have their own name, Fendusaurus eldoni.
Okay.
They were found with gastrolith.
Gastroliths, stomach stones, right, to help grind food.
Exactly, like gizzard stones. But not only that, they were also found with a bone from a small reptile, a sphinodont called Clevosaurus.
Wait, reptile bones with the dinosaur and the stomach stone?
Yep. Which has led to the suggestion that these early sauropodomorphs, and possibly Anchisaurus too by extension, might have actually been omnivorous.
Omnivorous, so mostly plants, but maybe snagging small animals or insects sometimes.
That seems plausible, yeah. This idea of occasional meat eating in these early forms is actually a really key insight. It suggests maybe a more complex early evolutionary path before they became the giant, dedicated herbivores we know later.
That makes sense.
Yeah.
And you mentioned later sauropods needed huge guts for plants.
Right. And that need for a massive digestive system to process all that plant matter is likely one of the factors that pushed them towards being fully quadrupedal, needing 4 strong legs to support that big body.
Fascinating connection. So we know the fossils were found in Connecticut, mostly. What was that area like back when Anchisaurus was alive?
Well, as we said, the main finds are from the Portland Formation, part of the bigger Newark supergroup in the Connecticut River Valley. And the geology tells us that back then, during the Hatangian and Cinemerian, maybe 200 to 195 million years ago, the environment was actually pretty arid.
Arid, like a desert.
Sort of, yeah, with really distinct wet and dry seasons. So a very different world from the relatively lush northeastern U.S. we see today.
Definitely. And didn't you mention similar aged rocks out west, like in Arizona?
That's right. The Navajo sandstone out there is the same age, geologically speaking, and they have found prosauropod remains in it, which have sometimes been tentatively called Amosaurus.
Oh, so maybe Anchisaurus or its close relatives were widespread?
Possibly. But there's still debate. Some paleontologists think those Arizona fossils might actually belong to Massospondylus, a genus that's much more common over in South Africa.
South Africa. Wow.
Yeah, it just highlights how fragmented the picture still is for these very early dinosaurs and how they were distributed across the globe back then. The continents were arranged differently, of course.
Absolutely. The early Jurassic was clearly a really pivotal time for dinosaur evolution and spread, wasn't it? And figuring out exactly how these early sauropodomorphs relate across different continents sounds like ongoing work.
Very much so. It's an active area of research.
Well, this deep dive into Anchisaurus has been absolutely fascinating. I mean, from mistaken identity with human bones
Yeah.
to all the naming chaos, figuring out its size, its lifestyle. It's quite a story. What are the main things that really stand out to you now that we've kind of walked through it all?
For me, the Anchisaurus story really underscores the whole process of science, how it's iterative.
Mm.
It's a perfect example of how our understanding of the past gets built piece by piece, often with initial mistakes, misinterpretations, and then this long process of refinement as we find more evidence.
The multiple naming attempts really drive that home.
Yeah.
How challenging it was for those early paleontologists just to get a handle on classifying these completely new kinds of creatures.
Exactly. And it definitely shows that our picture of dinosaurs isn't static. It's not set in stone, pardon the pun.
Okay.
It's constantly being updated, revised based on new discoveries and new ways of analyzing them.
Yeah.
And beyond just the scientific process, Anchisaurus itself gives us this really valuable window into a critical time in dinosaur evolution. It provides clues about that big transition from smaller, maybe omnivorous, two-legged ancestors towards those truly enormous four-legged plant-eating sauropods that came later.
A crucial step on that evolutionary path.
Definitely.
So as we wrap up this deep dive, here's a final thought for you listening. Think about how many other stories like this one, like Anchisaurus, might still be out there. Tales of mistaken identity, tangled names, evolving ideas, maybe hidden away in museum drawers or still buried in rock layers somewhere. What other scientific stories that we think are settled might actually hold some surprising twists? Twists that could reshape how we see prehistoric life. It really makes you wonder what's still waiting to be discovered, doesn't it? What else could rewrite the history of life on Earth?